My name's Steve Gillam. I'm a new professor, started last August in the physics department. I teach physics and astronomy. One of the reasons I was hired was to build the new astronomy minor, which our chair, Mark Masters, put in place in 2012. My research interests are globular clusters. I've always been fascinated, just because really they're beautiful. They're huge collections, spherical collections of hundreds of thousands of stars, and this gives me an opportunity to do what I like to do most, which is surveys. My main interest right now is in what might be called a census of a number of very interesting globular clusters. I should say that I've recently returned to academia from engineering. My first job after graduate school was, well, actually my second job after graduate school was working at the Jet Propulsion Lab, and for the last nearly 10 years I've been working in spacecraft navigation. But over the last 20 years, what I've really done is worked in the space industry. Recently I had the opportunity to return to my first love, which I never really forgot in all those years, globular clusters. And, most of you probably know that globular clusters are what's often referred to as a test bed for stellar evolution, because all the stars in a globular cluster started out life at the same time and merely live at different rates. Well, in the last 10 years that's proven to be almost universally incorrect. With the advent of, with all the wonderful data coming from the Hubble Space Telescope and its ability to see in the ultraviolet, which we can't do from the ground, and its incredible precision, both of measuring positions of stars in globular clusters and its ability to measure really faint stars incredibly precisely, the brightness of faint stars, it's now become clear that almost all of the 170 globular clusters in the Milky Way are in fact harbour multiple populations, and these populations may well come from different globular clusters. They merged in the past, in the fairly distant past on the time scale of the universe. And so my interest here is, where did they come from? One might imagine a typical globular cluster being now the result of three globulars that collided and merged several billion years ago. Where did these come from? Well, in the case of some very distant globulars, distant in the sense of they're almost to the Andromeda, their orbits take them almost to our neighbour galaxy, the Andromeda galaxy, and in those cases it's beginning to look like they are remnants of globular clusters from primordial galaxies that have long since evaporated into the background around them and disappeared. Their stars and most of the other components have simply evaporated. So it turns out that the Milky Way, the typical galaxy, and the typical globular cluster are not the static, eternal, gravitationally bound objects that I at least learned when I grew up as an undergraduate. So this is my interest, and I'm working with an undergraduate right now to collect from Hubble Space Telescope some archival data, lots of archival data, including that magic ultraviolet filter, to look at a very distant globular and see what groups of stars are actually in it. Talking of undergraduates, since I started here I've worked with 5 now on a number of projects related to this one. And well, they're very enthusiastic, and it all helps to build up the awareness of the astronomy option in the physics program. I was recently awarded a faculty summer award for research, so I'll be working on globulars with hopefully some students. If there's a couple say they're going to be here in the summer, we'll be analysing this data and hopefully publishing an interim, a preliminary report at the beginning of the fall. What are my future goals? To extend this work to other clusters, in distant clusters in the Milky Way. That's going to take actually a search for a development of criteria, which we hopefully will get from looking at the one cluster I'm particularly interested in right now, and then extend that into the inner reaches of the Milky Way to see if, in fact, we can really say if any of the Milky Way was ever original, or if it isn't just a collection of things that appeared, accreted over the billions of years since the universe started, basically, and perhaps to extend that to distant other galaxies. I'm looking forward to the launch of the James Webb Space Telescope, which is going to be out there at about 1 million miles from the Earth at a point called a Lagrange point, which is a gravitational null between, well, in that case I think the Earth and the Sun, where it's going to have an unprecedented view of distant galaxies and distant globular clusters, among other things. And I'm looking forward to getting my hands on some of that data and proposing some research using some observations using that instrument.